Okay, again, a very good morning to all of you and welcome for those who are just being here. So, this is chapter 6, the second content standard 6.2, nuclear energy. So, yesterday we have discussed the first part of this chapter, 6.1, radioactive decay. So, students, what is radioactive decay, or sometimes it is called as radioactivity? So radioactivity or radioactive decay is a spontaneous disintegration of unstable nucleus, to become more stable nucleus by emitting radioactive rays. All right, and we have learned there are three types of radioactive decay involving alpha decay, beta decay, and gamma decay. And in some process, the unstable nucleus can emit more than one radiation at the same time. Okay, so today we continue with 6.2 nuclear energy. This topic is covered in your textbook from page 208 until 217. Okay, there will be five learning standard here. So what will be our first one is to understand or communicate about nuclear reaction, which are nuclear fission and nuclear fusion. So before we start with this lesson, can we look at some exercises yesterday on 6.1? Can you open your workbook, page 135, students? Workbook, page 135, the objective question. Okay, we try check first a few example of question on 6.1. Are you there? Page 135. Okay, question number 1. What is the answer? Okay, while waiting for the others, we do some exercises first on yesterday topic. Okay, on page 135, question number 1, you are given an information to show equations of nuclear fission for uranium 235. Okay, this one actually refers to 6.2. Okay, so uranium is bombarded with neutron there, so it produced two new element, barium and krypton, release one three neutron and X. So can you guess what is X? Can you guess what is X? Yes, X is energy. Okay, yes, it's energy. What kind of energy? This is nuclear energy. For number one, we will learn it just in a while. Okay, what about question two? Okay, this one relates to yesterday's topic. Okay, question number two, diagram one shows a series of radioactivity. Okay, now we are discussing exercises in workbook for just those who are just being here. Page 135. Now question number two. Okay, diagram 1 shows a series of radioactive decay from uranium 238 to radium 226. So the question is, how many alpha and beta particles are released from this process, students? So how many alpha and beta released from diagram 1? So how to look? Okay, first if you look on the left on top, we have uranium 238. Okay, decay into thorium 234. So you can see the nuclear number decreases by 4 from 238 to 234, while the proton number decreases by 2 from 92 to 90. So here what particle is released? Here it release alpha. Okay, and then from thorium 238 to palladium 238. Okay, no changes on the nuclear number, but the proton number increases by 1. So release beta there. Okay, then from palladium 234 to uranium 234, no changes in nuclear number, but proton number increased by 1. So 1 beta is released there. Okay, and then from uranium 234 to thorium 230, so it release 1 alpha. How we know? Proton number decreases by 2, nuclear number decreases by 4. And last, from thorium 230 to radium 236, it released alpha. So how many alpha released there? we have 3 alpha release and 2 beta. So answer is boy. Yes, Jihang, answer boy for number 2. This process release 3 alpha and 2 beta. Who can see, able to see? There are 3 alpha and 2 beta there. Give me a thumbs up. Siapa boleh nampak sana ada 3 alpha, 2 beta? You can click on the thumbs up. Okay. Okay, number 3, students. Among the following, which one is not true about radioactive decay? So you highlight which one is not true about radioactive decay. Okay, A, produce radioactive radiation. This is true. B, produce most stable nucleus. Yes, this is true. Occur spontaneously and randomly. Yes, this is true. So the answer will be donkey. Increases the mass of nucleus. Okay. So the untrue is donkey. All right. Okay. What about number 4? This is involving half-life, students. Number 4. Question number 4, page 135. Okay, the initial mass of radioactive element is 10 gram. Okay, and its half-life is given 6 days. So which of the following statement is true about the mass of the radioactive element? Okay, which one is correct? Now its mass is 10 gram and it has a half-life of 6. So which one is correct? A, B, C, or D? Okay, Ji Hang say A. What about the rest? What do you say for number 4? The question is which one is true about the mass of the radioactive element? So A, 6 days earlier, it mass 20 gram. Okay. Or 12 days earlier, mass 80 grams. 6 days later, mass 2.5. 12 days later, mass 5. So which one? Answer yes. Answer is A. 6 days earlier, it mass 20 gram. So every 6 days, the mass will be reduced by half. All right. Okay, number 5, students. Okay, this one again about half-life. They give you uh half-life there for an element X, sample X. It became 6.25% of the original value after 120 minutes. Okay, from the chart there, from the arrow show there, how many half-life you can see there? How many half-life? Okay. Yes, it shows 4 half-life. So it shows 4 half-life. So what is the half-life for sample X? So how to do? 120 minutes divide 4. Okay, so answer will be 120 minutes divide by 4 number of half-life. So which means the half-life for sample X is, yes, it is A, 30 minutes. Okay, the half-life is 30 minutes. Every 30 minutes, sample X will be decreases by half. Okay, so after 120 minutes, the number of left undecay is 6.25%. So number 5, answer half-life is 30 minutes. All right. Okay, what about number 6? Okay, number 6, the equation show the decay process of lead. Okay, so initially we have lead 214 and then decay to bismuth 214, and this process release X and Y. So can you determine, identify what is X, what is Y? Okay. What is X? What is Y? If you look at the nuclear number, no changes, right? Before is 214, after total also 214. And on the proton number or atom number, 82. On the other side is 83, then minus 1. Okay. So can you guess? So answer yes, answer X is beta. X is beta. 0, -1 is electron. So that is beta. So Y is gamma. Yeah, answer is boy. X beta, Y is gamma. Okay, next question on the next page. 136 students. 136. Okay, number 7. Half-life of a sample of radioactive material is defined as. So what is half-life? So we understand from yesterday's discussion, half-life is, yes, time taken for the activity of the sample to become half from the initial or original activity. So number 7, answer also boy, B. All right. Okay. Okay, then let's check last question for objective question number 8. Okay, what do you say? Question 8. Okay. Even the initial mass of radioactive element is 40 gram and its half-life is 10 days. Okay, initial sample 40 gram, initial mass, half-life 10 days. So which of the following statement is correct? Okay, about the mass of the radioactive element. Okay, which one is correct? Number 1, 20 days earlier, it mass 180 160 gram. Okay. 20 days earlier, it say it mass 160 gram. Then number 2, 10 days later, it mass 30 gram. Or number 3, 20 days later, it mass 10 grams. So which one is correct for number 8? Okay. Now it's mass 40 and half-life is 10 days. So which one is correct? So 20 days earlier, it bears 10 gram, 160 grams. So this is correct. 20 days before, it is 160 gram. Second, 10 days later, this is wrong because 10 days later, the mass is not 30 gram, but 20 gram. Okay, so number 3, 20 days later, its mass is 10 grams. So answer is number 1 and number 3 correct. So for this, answer is C, number 1 and 3. Okay, so that is the objective question on half-life. Okay, now can we check for structure question number 1, student? Structure question number 1. Have you did this or not yet? Who have done question number 1, page 137? Okay, those who have done, give me a thumbs up or you can type on the in-call messages, me. Okay. Or if you didn't do yet, no problem. We do it together now. Okay, number 1, you are given diagram 1. Students, it shows activity time graph for potassium 42. Okay, potassium 42 emits beta particle and used as a tracer to measure the quantity of salt in the human body. Okay, for the first question A, state one characteristic of beta particle. Student, this is a straightforward question. Okay, basic question on properties of beta. So what can you say about beta particle? Give one characteristic of beta particle. Okay, high velocity. Any other answer? Yeah, it is a high velocity electron. Electron move with high velocity. You can also say it is a negatively charged particle. Okay, negatively charged particle, which move at high velocity. Okay, what about B, student? Based on diagram 1, can you state the half-life of potassium 42? What is the half-life of potassium 42 from the curve on diagram 1? Yes. So how to see the half-life? Yes, 12 hours. Initial content 1600. So the half-life is when it reduced to 800, half. So the time there, you have to do interpolation, student. Interpolation of graph from 800, you draw a straight line to the curve. So the time will be 12 hours. So correct, Jaren. Answer 12 hours, the half-life for potassium 42. Okay, what about C? Based on the half-life, why is potassium 42 suitable to be used as a tracer in human body? Student, think logic. Why potassium 82 suitable to be used as a tracer to measure quantity of salt in human body? Okay, think logic. Low ionizing power. Any other answer? The question asks you based on the half-life. Okay, based on the half-life. Okay. Is 12 hours long or short half-life? What do you think? 12 hours long or short half-life? Okay. 12 hours. Do you think it is a long or short half-life? Okay. Jaren say long, question mark. What about the rest? What do you think? 12 hours. Is it suitable to be a tracer in human body? Okay. So actually this 12 hours consider as short half-life. Okay. So it can be disposed from human body in shorter time. Dia tak perlu berada lama dalam badan manusia. Okay. If the half-life is 1 month, then it is not suitable. Okay, then it will stay longer in your bloodstream. So the answer is it has a short half-life and safe to be implied to the patient. Okay, it has a short half-life and safe or bring no harmful to the patient as it won't stay longer inside the body. Okay. Low rate half-life. Kita panggil short half-life, Cihang, short half-life. Okay. Okay, now D, do some calculations, student. Find the time taken for potassium 42 to reduce to 1 to 8 of its initial activity. Okay. So how to do this? Calculate time taken for potassium 42 to reduce to 1 over 8 of its initial activity. Okay, so what is the time taken to reduce to 1 over 8 of its initial activity? So how many half-life involved there, students? Okay, how many half-life involved there? So if you are given a fraction, okay, how to do that? Okay, if you are given a fraction. So in fraction, initially the content is 1. Okay. After the first half-life, the content reduced to half. So the fraction is half. Okay. Then after the third half-life, it reduced to quarter. Okay. Quarter is half from 50%. Then it reduced to 1 over 8. Okay, so this one. So the question asks you calculate the time taken for potassium 42 to reduce 1 over 8 of its initial activities. So what is the answer? So here 12 hours, here 12 hours, so here 12 hours. So 3 half-life involved there, which means the total time is 36 hours. Okay, I'm sorry about the writing. My mouse is quite lag here. So answer is 36 hours. Okay, 36 hours. All right. Okay. So are you clear with D? Okay. Okay, now that is a few exercises on half-life. Later we continue. So now we begin with our lesson with standard, the first learning standard to communicate two types of nuclear reaction. The first one is called nuclear fission and second one is called as nuclear fusion. Okay, so this is the comparison between nuclear fission and fusion. Sorry. Okay. So first, let us take a look at how does nuclear energy produce. Okay, how does nuclear energy produce? So nuclear energy is produced from a process called nuclear reaction. Okay, and as we see, there are two types of nuclear reaction. The first one is called as nuclear fission, Fission, and the second one is called as nuclear fusion, Fusion. So what is nuclear fission, student? In nuclear fission, as you can see from the slide, it is the splitting, okay? The splitting of heavy nucleus into two lighter nuclei. And this process release a large amount of energy. Okay, so you can see this is the heavy nucleus there. It is bombarded with neutron. So in this process, it is not occur naturally. This is not a natural process. The process will occur when there is a neutron attack or bombard a heavy nucleus. So what happened to this heavy nucleus? It will split into two or more lighter nuclei. See, this unstable nucleus bombarded with neutron, so it's split into krypton and barium. And this process release another three neutron and a very large amount of energy. Okay, that is nuclear fission. And then what about nuclear fusion? Nuclear fusion is the other way around. It is the combination or the fuse, okay, of two lighter nuclei to form a heavier nucleus with the release of large amount of energy. So it is an opposite process. Fission is a splitting of heavy nucleus, while fusion is a fuse or combinations of two lighter nuclei to form one heavy nucleus. And this nuclear fission, it is a natural process. Occur where? Occur at the surface of a sun. Okay, di permukaan matahari. Okay, next, student. Okay, for example there, you can see we have one hydrogen atom there combined with another hydrogen. I think this is deuterium combined with tritium and it is produced one heavy nucleus. Okay, a new heavy nucleus. And this process also release one neutron and nuclear energy. So you can also see there is radioactive radiation emitted in this process. Okay, so that is the first difference between fusion and fission. Okay, then this is another example of fission. We have uranium-235 nucleus there bombarded with neutron. So it became 235 uranium-236. Okay. This uranium-236 is highly unstable, so it will quickly split into two daughter nuclei together and release three neutron plus energy and also emitted some radioactive radiation. Okay, this is the uh, equation. Okay, the equation as we see in question one just now in the objective question. Okay, so when you see the front equation here, the reactants, uranium is bombarded with neutron. So you know this is nuclear fission. So this is the new product. Okay, two lighter nucleus plus three neutron and energy. Okay. While example of fusion, as I mentioned just now, we have a light nucleus, deuterium, and tritium. Actually, deuterium and tritium is a radioisotope for hydrogen. Okay, so they fuse together to produce heavy helium nucleus. And in this process, it releases neutron and a very large amount of energy. Okay. Um, for this nuclear fission, it occurs under very high temperature and pressure, where at the surface of the sun. Okay, and this is the example of equation. So if you look at the equation, this is the fusion. Okay, the fusion process, no neutron present there. Okay, so this is the difference between equation for fission and fusion. All right. Okay, next student. Okay, so this nuclear fusion, okay, in nuclear fission process, it can lead to a chain reaction. So what is a chain reaction in chemistry? Also, you learn about chemical, a chain reaction. It is a continuous reaction, initiate from one to another reaction. So in chain reaction, what happened? It is a self-sustaining reaction in which the product of the initial reaction can initiate another similar reaction. So the reaction occurs continuously. So it forms a very long chain reaction as shown in this chart. Okay, so this is what the nuclear fission initially, a neutron bombarded uranium-235. So this process released three new neutrons. So later, this neutron will attack another uranium-235. So it produces another three neutrons. So then it attack the next uranium-235. So this process occur continuously. All right. So a lot of energy will be produced from this chain reaction. All right. Okay, next. Okay, so if you look at the details here, what happened in chain reaction. So since more neutrons are produced, causing a chain reaction until the mass of the uranium nucleus reach a critical mass. Okay, so every time the reaction occurs, so definitely the mass of uranium will be decreases and decreases and decreases until it reach critical mass. So what is critical mass? Critical mass is the minimum mass, okay, of nuclear fission that will sustain a nuclear chain reaction. All right. Okay, and as the uranium continue to split, it will produce a very huge amount of energy, and we can calculate using this equation. E equal mc squared. This is Einstein equation. Okay, E equal mc squared. So what is the use of this energy produced in this chain reaction? It is used to generate electrical energy in some countries which use nuclear sources to generate their electricity. For example, Russia, US, India, Japan, and a few more countries in the world. All right. Okay, so this chain reaction normally occur in a nuclear reactor. Okay, it must be controlled or otherwise it will be a catastrophe. So it must happen in a closed control container where in a nuclear reactor. We will learn that later on. All right. Okay. Then also it will use to produce nuclear bomb lah as well. Okay, which is before use in World War you learn in history. Okay, next student. So this is the comparison between nuclear fission and nuclear fusion. Okay, first we talk about the similarity. Okay, both process release a very large amount of energy. What is the name of the energy? Nuclear energy. Okay, second, it occurs to the nucleus of the element. And the third similarity, in both process, new element is formed. For nuclear fission, it form two lighter or two or three lighter element. Okay, for nuclear fission, it form one heavier element. Okay, and both process also produces mass defect. What is mass defect? Mass defect is the loss in mass along the process. So actually, this mass is not lost to the surrounding, but the mass defect is the mass of the particle that converted into kinetic energy. So mass defect is equal to the kinetic energy produced in this reaction. Okay, what about the differences? As we talked earlier, fission does not occur naturally. Okay, it requires a neutron to start the process. A neutron need to be bombarded to unstable nucleus uranium-235. While for fusion, it occurs naturally on the surface of a sun. Okay, then, for fission, the process of slitting a heavy nucleus to form a lighter nuclei, while fusion, it is a combination of fusing of two or more lighter nuclei to form a heavier nucleus. Okay, another difference for fission, it is initiated by slow neutron and does not need high temperature, while for fusion, it occurs in a very high temperature and pressure. Okay, so the last differences, for fission, it produces large number of nuclear waste, while no waste is produced for fusion. All right, so you can see the similarity and the differences between nuclear fission and fusion. Okay. So done with the first learning standard. Are you okay, student? Nuclear fission and nuclear fusion. Can you understand? Can you differentiate them? Okay, if you do, give me a thumbs up or you can say yes in the in call messages. All right. So now let us go to the second learning standard. Okay, before that, let us take a look at one exercise in your book. Okay, page 131, student. Please go to page 131. 131. Okay, 131, look at there, 6.2 nuclear energy. Question number 1, can you write the type of nuclear reaction for each of the equation given? Okay, 1A, what is the reaction? 1B, what is the reaction? Which one is nuclear fission? Which one is nuclear fusion? How, which one is which? 1A, or fission. And 1B, nuclear fusion or fission. Which one? So the first equation, we have uranium-235, okay, plus neutron. So the product is uranium-236 and barium-144 plus krypton. So 3 new daughter nuclei produced there. So yes, Jaren, A is nuclear fission, okay, and B, we have deuterium there fused with tritium, so it produces heavier helium nucleus and process release one neutron and energy. So B is fusion. Okay, A is fission, B is fusion, nuclear fission, nuclear fusion. Okay, then number 2, can you complete the sentence below, students? 2A. Okay, 2A. This is the definition for fission and fusion. Okay, 2A, what to write there to complete the sentence? 2A is a definition for nuclear fission. Okay, nuclear fission is a nuclear reaction that occurs when what? When who splits? When? Can you complete the sentence? Nuclear fission is a nuclear reaction that occurs when, yes, a heavy nucleus. Yes, answer is when a heavy nucleus. Good, Jai. When a heavy nucleus split into what? Split into what? Lighter nuclei. Split into how many? Two or more. It can be two or more. Okay. It can be two or more lighter nuclei. Okay, by releasing what? Large amount of second answer, two or more. Not only two, not necessary two, it can be more than two. So answer, two or more lighter nuclei by releasing large amount of energy. Yes, very good. Okay. So, what is nuclear fission? It is a nuclear reaction occurs when heavy nucleus split into two or more lighter nuclei by releasing large amount of energy. Okay, what about B? This is the definition for nuclear fusion. So, nuclear fusion is a nuclear reaction that occurs when what? When what and what combine to form? When small and light nuclei. So answer is when small and light nuclei. Kecil dan ringan. Okay, when small and light nuclei combine, okay, to form what? To form a heavy nucleus. Okay, a heavy nucleus. Okay, by releasing large number of energy. All right. Why sometimes nuclei? Why sometimes nucleus? Simple. Nuclei is plural, student, because in fusion we combine two or more nucleus. So we say small and light nuclei. Okay, combine to form. So the product is only one single heavy nucleus. Okay, and this process release a large amount of energy, occurs under extremely high temperature and pressure. Where? At the surface of the sun. Okay, so we continue with the next exercises. So let us take a look at the second learning standard now. Okay, now this is to describe what is the relationship between the energy release during nuclear reaction and the mass defect. Okay, from this equation, as I mentioned just now, actually the mass defect is converted into energy during this process. So we can find using equation of E equal to mc squared. Okay. So now you understand both process, fission and fusion release a large amount of energy, and these sources of energy is from the loss of mass or the mass defect during the nuclear reaction. And students, from the equations of both process, the sum of masses of the particle before reaction mean on the left is more, okay, is more than the sum of masses of the particle after reaction. So here we understand there is sum of the mass loss along the process, which is called as mass defect. So this is the formula for mass defect. Sum of mass before reaction, Mi, mass initial, minus sum of the masses after reaction, Mf, final mass. Okay, and this is the short equation. M equal Mi minus Mf. Okay, for example, later we will see how to count mass defect. All right. Okay, so this one number 4. Again, this mass defect is not actually lost, but they have convert into energy. Okay, so this is the energy. E is the nuclear energy produced. M is the mass loss or mass defect in the process. And C is the speed of light. Okay, 3 times 10 power of 8 meter per second. So this one, E equal mc squared. And student, for this nuclear energy, it can also be stated in the unit of electron volt, EV, okay, as you calculated in the cathode ray oscilloscope, okay. So 1 electron volt equal to 1.6 times 10 power of negative 19 joule, right? Okay, so there are two units you can state the nuclear energy process, but normally we write in terms of joule, right? Okay. So the next slide, okay. So due to the masses of atom and subatomic particles is being too small, So we use a convenient unit, which is atomic mass unit. I believe you understand this since you learned them in chemistry. Okay, so they took carbon 12 as the references to put this 1 AMU in a standard value. Okay, where the mass of one carbon 12 is 12 AMU. So which means 1 AMU is equal to 1/12 of the AMU from the mass of one carbon 12 atom. Okay, and you learn in chemistry also 1 mole of carbon equal to 12 gram, which mean in 1 mole of carbon, how many atoms are there? So we have 6.02 times 10 power of 3 atom. This is also known as Avogadro number. Am I right? Betul ke you panggil dia nombor Avogadro? So therefore, for one carbon atom, what is its mass? The mass is 1.99 times 10 negative 23. So this is just for your understanding. Okay, so by this, we understand one atomic mass unit equal to 1.66 times 10 negative 27 kg. So this is the equivalent. 1 AMU equal 1.66 times 10 negative 27 kg. So why we want to know this? Because when you calculate, when you apply E equal to mc squared, the unit for mass there must be in kg. Okay, the unit for mass in the equation must be in kilogram. Alright, okay. So now let us check on a few example of question. Apply that equation of E equal mc squared. Okay, look at this equation number 1, student. You are given this equation to represent radioactive alpha decay which occurs spontaneously. So we have a radium there, radium 226, decay into radon 222, and this process release helium or alpha. Okay, so you are given a table, give you the atomic mass unit for each of these elements. Okay, this is the AMU for radium, this is the AMU for radon, and this is the AMU for helium, which is alpha. And this is the additional information you are given. 1 AMU equal to 1.66 times 10 negative 27 kg. Alright, so the question asks you first to determine the mass defect in kg. So how to find mass defect in kilogram? Remember what is the formula for mass defect? Mass defect is the mass before, total mass before reaction minus total mass after reaction. So you will find the mass defect. Okay, for example, okay, this is the equation. Mass defect, initial mass before reaction minus total mass after reaction. Okay, so this one in AMU. Okay, first in AMU. So before reaction, we have radium. So it is 226.025. You must take all the number. Okay. And after reaction, we have radon and helium. So this is the total mass after reaction for radon and helium. So we have 0.004 atomic mass unit. Okay. So they want you to put the answer in kg, kilogram. So you have to convert into kilogram by multiplying with this factor. Okay, multiply with this factor. So in kg, the mass defect is 6.64 times 10 negative 30 gram. Right? Okay. Then second, they ask you to find the energy release from this process. So what formula is to apply? E equal mc squared. Alright? So this is the mass defect in kilogram multiply speed of light squared. So, if you calculate, can you press your calculator, check my answer. Is it correct or wrong? Okay, so from here we find the energy 5.976 times 10 power of negative 13 joule. Okay, the nuclear energy released in this process. Okay, are you clear with problem solving one? Can you understand the solution? If you do, let us try one exercises there. Question number 3. Okay, question number 3. Okay, how to answer that? On page 132. Diagram shows nuclear fission. The question is, explain how nuclear energy is produced from the nuclear reaction in the diagram above. Okay, how, student? You can relate to the mass defect for this question. Okay, question 3. Okay, how to explain? So you can say there is a large mass defect. Okay, there is a large mass defect. Okay, where this mass defect convert into energy. Okay, answer for number 3, the explanation. There is a large mass defect. And this mass defect converts into energy. Okay, where the total energy produced is calculated by E equal mc squared. Okay, that is the explanation. Okay, I repeat, there is a large mass defect. Okay, where the mass defect converts into energy, where the total energy is determined by E equal mc squared. So that is the explanation on how nuclear energy is produced from the nuclear reaction shown in diagram for question 3. And can you tell me what process involved there? What is the nuclear reaction occur in number 3? What is the name of the nuclear reaction? You can see there is neutron bombard uranium-235. So the process is nuclear fission. Yes, Jiwei, nuclear fission. Okay, now let us calculate the energy produced in number 4. Okay, according to problem solving 1. Okay, question 4, they give you information to show equations of nuclear fission of uranium-235 nucleus. So you can see on the left, we have uranium and neutron, and the product, we have barium 141, krypton 92, 3 neutron, and energy. Okay, they give you the information, all the atomic mass unit for uranium 235, barium 141, krypton 92, and neutron. Okay, so there are 4 products there. Barium, krypton, 3 product. Okay, barium, krypton, and neutron. Alright. Okay. For the reactant, we have 2, uranium and neutron. So can you find the mass defect in this process? Okay, I give you about 1 minute to find the mass defect first in kg, student, for question 4a. So the reactant, we have 1 uranium and 1 neutron. The product, we have 1 barium, 1 krypton, and 3 neutrons released there. So how to find the mass defect? You can follow example in problem solving 1 to find the mass defect in kg. If you're done, you can type your answer in the in-call messages so we can compare. Either you get it right or not. Okay, so I hope everybody's trying there. Work with your calculator and familiar yourself with this question. Okay, Chia, you got 2.988 times 10 negative 28 kg. Okay, what about the rest? What did you get? Did you get the same answer? Jiaran says same. What about the rest? Anyone got different answer? Okay, so yes, answer is correct. Okay, very good, Chia Yi. So you find first. So for the initial mass, we have two there. The mass for uranium and mass for neutron, and then minus with the sum of mass of barium, krypton, and three neutron atom. Remember, okay. Don't forget to multiply 3 for the neutron because there are 3 neutron released there as the product. So the answer 2.988 times 10 20 negative 28 kg. Correct. Okay, now B, find the energy released in the reaction. Okay. So the question is similar to this problem solving number one. Find the energy released in the reaction. So use E equal to mc squared. So the mass, use the mass you calculated earlier in kg, multiply c squared. Please don't forget to square the speed of light. Okay, this is also can be considered as one of the question the student do a lot of mistake here. Okay, um, by not putting the square for C. Careless mistake. So please try to avoid careless mistake. So how much energy is released? Yeah, you say 2.6892 times 10 negative 11. Okay. Same to Jiaren also. What about the rest? What did you get? Okay, do you agree? So answer yes, correct. 2.6892 times 10 power of 11 joule. Please don't forget the unit as well. Okay, the energy is in the unit of joule. Okay, so I guess you get this right, understand. Okay, now let us proceed with the next example in this book. Okay, now we have this equation. Okay, this equation. So can you tell me what process involved here, students? According to this equation, what process occur here in problem solving two? Yeah, very good. Nuclear fusion. Fusion 1S, Jai. Nuclear fusion single S. Fusion. Fusion. Fission double S. Alright. Okay, so we have deuterium there react or fuse with another deuterium atom. So it produce heavier helium element. And this process release one neutron and nuclear energy. So based on equation, X is the nucleus of helium. Okay. Can you find the value of X, student? X is the nuclear number of helium. Okay, X is the nuclear number of helium. Can you find what is the value of X according to this equation? Okay, what is the value of X? So on the left side, total is 4. So on the right, total also must be 4. So down here, total is 2. So on the right, also total 3. So answer yes, X is 3. So X is 3 equal to 3. Correct. Jia Yi Ji Wei, correct. X is 3. Simple mathematics. Okay, state the type of nuclear reaction. Okay, so what type of nuclear reaction? Nuclear fusion. Okay, nuclear fusion. Okay, 1S, Jaren, fusion, nuclear fusion. Okay, next. Okay, now number 3, student. Nuclear reaction release a large amount of energy due to mass defect. So again, you are given this table, AMU for each. Okay, deuterium and helium together with neutron. And this is the conversion, one atomic mass unit equal to 1.66 times 10 negative 27 kilogram. You are given the speed of light as well. So find the mass defect. Okay, from this equation, find the mass defect. Okay, in 1 minute, find the mass defect. And when you're done, find the energy released in this process. Okay, what will be the mass defect? So initial mass, we have two deuterium atom. So the final mass, we have helium and neutron. So this will give you the mass defect, Mi minus Mf. Total mass before reaction minus total mass after reaction. So this is the value. We have two deuterium element there. So minus, this is the mass for helium and this is the mass for neutron. Okay, so answer will be 0.0035 U. Okay, for this question, they didn't ask you to put in kg, right? So you can leave your answer in atomic mass unit. Okay, or you can also leave it in kg, no problem at all. Okay, but then later in question 2, when you find the energy, still you have to convert this into kg. So answer will be 5.229 times 10 negative 13. Can you check for my answer? Is it correct or not? Oh, the energy released in this nuclear fusion process, 5.229 times 10 negative 13 joule. Is it correct? Who else we have here? Who keeps silence? Wai Ching, is it correct? Yiwen, Roshuan, yes, correct. Zan Hong, are you doing the calculation? What about you, Jia Hao? Jingming, are you doing good there? Ruyang, Seyong, Jia Yin, we also have Ming Xin there, Junbin, and Zongqian as well. Okay, yes, correct. Okay, very good. Okay, now let us move to the next slide. Okay, so this is the tips to apply this equation. Mass defect must be in kg, students. Okay, next. Okay, the four learning standards. Okay, now if you look at this GIF, this is what the situation inside a nuclear reactor. So, learning standard 4 is to describe generations of electrical energy in a nuclear reactor. Have you learned this anyway in lower form? Ada belajar tak nuclear reactor in lower form? Okay, so this is again the structure of a nuclear reactor. Okay, you can see the reactor there. This is the generator, the cooling tower, and finally the power cable is the power transmission system. Okay. Okay, so first the components then to know the components. So there are a few important components. You must know the function. The first one is the reactor itself. Okay, what is the function of this reactor? To produce a large amount of energy from a process called nuclear fission. So if they ask you what process occur inside nuclear reactor, answer is nuclear fission. Fission. Second, we have uranium fuel rod. So where is the uranium fuel rod? So this is the uranium fuel rod. So the fuel we are using uranium rod. Okay. So what happened here? The nucleus split by neutron in a control chain reaction release a large amount of energy. This energy later on heats up the cold gas passed through the reactor core. Okay. Then what else we have? The third component is a graphite moderator. You can check from the diagram where is the graphite moderator. Okay, the function of graphite moderator is to slow down the fast moving neutron. Okay, to slow down the fast moving neutron. Okay, and fourth, we have boron or cadmium control rods. So what is the function of this control rod is to absorb excess neutron. okay, is to absorb excess neutron or to control the rate of reaction inside the nuclear reactor, right? So number 3 and number 4 is an important parts. Okay, kadang-kadang dia tanya dalam soalan, what is the function of graphite moderator to slow down fast moving neutron? What is the function of cadmium or boron control route? Is to absorb excess neutron or to control the rate of reaction. And then we have a part they call the heat exchanger. This is where used to heat, okay, energy from a very hot get used to boil the water into steam to convert water into steam. Okay, then we have a concrete shield. Okay, the wall of the reactor made from a concrete shield, thick concrete shield. Why? To prevent leakage of radiation from the core to the surrounding. Okay, and we have coolant there at the important part. This is to absorb, okay, the heat produced during the process. And normally for the coolant, we are using water or carbon dioxide. Why using water? Because it has a very high specific heat capacity. Okay, so they can absorb a lot of heat with a low rise in temperature. Okay, that is the parts and function inside the reactor. Okay, now to understand how the process occur, okay, or how we use nuclear energy as an alternative energy to generate electrical energy. Okay, so this is the fifth and the last learning standard. Okay, first student, this is a few example of fuel which can be used to generate electricity in different country. Some are using coals. Some country using hydropower as like us in Malaysia. We are using hydropower station to generate our electricity. And there we have nuclear energy. Okay, first, compare on the construction cost for each. Okay, it is medium cost for coal, high cost for hydropower and nuclear. For hydropower, we need to build the dam as well, so it need a very high cost. And of course, for the nuclear, you need to find a very strategic place away from residential area to build the reactor. Operation and maintenance costs. For coal, it require very high maintenance, even though the construction cost is cheaper. And low maintenance for hydropower and nuclear. That is the advantages. Okay. What about the location of the plant? For coals in a secluded area far from human settlement, because for this coal power reactor station, it produce a lot of soot, a lot of black smoke, which can affect the resident health. Especially, it can cause a lot of respiratory problems to humans. While for hydro, it must build near river, okay, or dam because of the water supply. Okay, while for nuclear, same, it is normally built at the shore. If you notice, most of the nuclear power plant are built along a shore. Bina semua di tepi laut, pesisir pantai, because a lot of coolant supply from the shore. And the effect to the ecosystem for coal, it produces a lot of air pollution. It causes a lot of carbon footprint. Okay, while for hydropower, it will cause deforestation. You need to chop down trees to build the dam and the reactor as well. So, but it has clean and no carbon footprint. Carbon footprint means it release less carbon dioxide to the atmosphere. And for nuclear energy, it produces a very clean and green energy. Okay, clean and no effect to the ecosystem. Okay, then student, what is the next comparison between these three sources of electricity? According to the safety and health issue, for coal, again, release a huge amount of carbon and causes severe air pollution. For hydropower, so far, it can use to control flood. Okay, No health issue has been arise until today. For nuclear, it is a highly secure area storage system, high risk of leakage. This is one of the disadvantages. If you remember, the tragedy occurred in 2011, if I'm not mistaken. Okay, where in Japan, when the power plant is explode. Okay, I don't remember the place. Is it the place is in Japan? You can search from the internet. Okay, until today they can feel the effect. Okay, of the blast of the nuclear power station there on that year 2011, if I'm not mistaken. Okay, from the technology and expertise for coal, it used low safety issue but cause high health issue. Okay, for hydropower, it requires high technology and expertise, especially in electrical field. And for nuclear, it require more. Okay, high technology and expertise, not only in nuclear field, but also expertise from some engineering fields. Okay, in terms of waste management issue for coal, it produces a lot of waste such as mercury, heavy metal, and also expensive control system for both air and water pollution. Okay, for hydropower, no waste to be managed. Okay, and for nuclear, it needs high expertise to manage the waste product. So the nuclear waste product cannot simply them, okay, here and there. So it need a high management expertise. Okay, so that is about nuclear energy, how it used to generate electricity. Okay, now let us take a look at this question, student. Okay, before that, can you go to page 133? 133. Can you label the parts there? PQR. They give you diagram show three component in a nuclear reactor. P, Q, and R. Okay, you can refer back to your module. What is P? And write the function as well. Okay, can you name the part first and later you can write the function according to your module. P used for what? What is the function for P? What is the name of part P, student? Part P. What is the name of P? Look carefully. Where is the label placed at? Okay, P is the control, control road. Okay, control road. Q is the moderator. And R is the fuel road. Okay, uranium road. R is the uranium road or the fuel road. So P is control road, Q is the moderator, and R is the fuel road. So control road, what is the function? To absorb excess neutron. Okay, moderator, to slow down fast moving electron. Okay. Sorry, to slow down fast moving neutron, not electron. To slow down fast moving neutron. Okay, and R, the function for the fuel is to produce nuclear energy through nuclear fission process. Okay, you can check back later from the table. Okay, now let us see these practices. Okay, question 1, student. Okay, why uranium-236 split into two new elements after the reaction occur? So according to this diagram, what kind of reaction we have there? We have nuclear fission. Okay, nuclear fission. A neutron is bombard uranium-235, so it become uranium-236, a highly unstable. So it will quickly get split into two new element, which is more stable. Okay, and this process release three neutron element. Okay, so the reason when uranium-235 bombarded by a neutron, so it formed uranium-236, which is very unstable. So it need to split rapidly to form a new, more stable element or nuclei. That is the reason. Okay. Moderator, not rightful word. Can moderator, yes, moderator. Graphite moderator will be better, of course, but moderator also accepted. Okay. Same with the control road. You can write control road or you can write boron control road or cadmium control road. Okay. Okay, next. What about the next question? Okay, students, now they give you this table. Okay, table 3. It shows an equations of reaction and total atomic mass before and after nuclear fission. Okay, this is table 3 on nuclear fission. And table 4, this is an equation of a reaction and total atomic mass before and after nuclear fusion. So we have two tables there. The first table is on nuclear fission. Second table is on nuclear fusion. Okay, so this is the equation before reaction, after reaction. Okay, and for nuclear fusion, this is the equation before reaction, and this is what happened after reaction. Okay, they give you readily the total mass before reaction and after reaction. This one also they give you readily the total AMU before reaction and after reaction. So the question asks you, by using only the information given in both table, compare nuclear fusion and nuclear fission reaction. Okay, how do you compare? Hence, state the relationship between mass and energy involved. Okay, how to compare? How to make comparison here between table 3 and table 4. First, what you can compare? Okay, you can compare the process. What is nuclear fission? It is splitting of heavy nucleus into two lighter nuclei. And nuclear fission, it is combining or fusing of two or more light nuclei to form heavy nucleus. Okay, this one also same. Okay, nuclear fission is the splitting of heavy nuclei into two or more lighter nuclei. Okay, the third comparison, you can compare the mass defect. There is mass defect in both processors. So you can mention total AMU before reaction greater than total AMU after reaction in both. Okay, here. Total reaction is 240 before. After is 239, so less. This one also before is bigger, 5.03. After 5.01. Okay, and then the fourth comparison, both process release energy. Okay, both process release energy, and the energy can be calculated using this equation. Okay, this is the relationship between mass and energy involved. The relationship is in a form of formula. Okay, the energy uh, generated equal to the mass defect multiply speed of light squared. Okay, and then see, they ask you to calculate energy release in nuclear fission, student. Okay, find energy release in nuclear fission. Okay, and for this question, the mass defect is readily given. They give you readily the mass defect. Okay, 0.18606. So for this one, you just put in the equation. So E equal to MC. So you took the mass given in AMU. Remember, don't forget to convert it into kg by multiplying with the factor 1.66 times 10 negative 27, and this is speed of light squared. Okay, so answer will be uh okay, cannot see the answer down there. Okay, 2 point, is that 2.78? times 10 negative 11. Okay. Is that 2 or 3 there? It is a block by this symbol, 2. Okay, 2.780 times 10 negative 11 joules. So this is the amount of energy released on this nuclear fission. All right. Okay. You can check on the full answer later. Okay, just refer to the full module I share in your Telegram group. All right. Okay. Okay, next question, student. Question 2. Okay, they give you a structure of nuclear power plant. Okay, first, what is meant by nuclear fission? Again, student, what is nuclear fission? So it is a process of splitting, okay, splitting of heavy nucleus into two or more. Please add there, two or more lighter nuclei and release large amount of energy. Okay. So how to find the energy produced here? They give you the mass effect readily. So very easy. You just put in the substitution. Yes, G, we're splitting of heavy nuclei into two or more lighter nuclei and release large amount of energy. Yes, very good. Okay, so for this one, okay, you can calculate the energy produced and check the answer with me. So answer 2.78 times 10 negative 11 joule. Okay, the mass effect readily placed in kg, students. So please be aware. For this question, the mass effect readily give in kilogram. So you just multiply with c squared there. Okay. So you have to be alert with the unit given on the mass effect. If readily in kg, so here no need to multiply with 1.66 anymore. It just took the value straight away and just multiply with c squared. Alright? Okay. Okay, next. Question 3. Okay, question 3. Okay, now a nuclear power plant in diagram is proposed to build in Malaysia. Okay, let's say we are planning to have a nuclear power plant in Malaysia. So can you give your suggestion based on the following aspects so the plant can be operated safely? So where to place the location, where to build at, student? Where to build at the nuclear power plant? Tadi tengok kan dekat mana suitable. Okay, at where? At the shore, near sea, near river, near any water resources. Okay, so normally it is built at shore. Why? Reason. Why we build there? Okay, easy access to water. Okay, easy access to water or easy access to coolant, or it can provide a continuous cooling system. What about the thickness of the wall of the containment building? So thickness of wall. So thickness should be thick, okay, thicker or higher. Why? This is to prevent leakage of radioactive radiation from the reactor core to the surrounding. Okay. And what material is suitable for the coolant, students? What material suitable for the coolant? So you have two choices. Can use what and what? Yes, can use water. Another one can use carbon dioxide. But normally we use water as the coolant. Why we choose these two? Okay, why we choose these two? What characteristic that they have to be suitable to be used as the coolant? So they can absorb more heat, or you can say it has a high specific heat capacity. Okay, they have high specific heat capacity, so they can absorb more heat. Okay, why not Freon? Kenapa tak Freon? Freon ni mahal, coolant gas, and you need a lot of coolant gas. Freon we didn't get for free. Okay, water you can take for free from the sea. Okay, yes. Okay. So Freon normally we use in air conditioning system and also in a refrigerator. Okay, as for coolant gas. Okay, next student. Okay, question 3. Okay, question 3. Okay, a slow nuclear reactor uses fission of uranium-235 for generation of electricity. Slow-moving neutron are used to bombard uranium-235. So this is the statement you are given. So first, explain why energy is released in fusion of uranium-235. So how the energy release? Okay, so this is how the energy release. Total mass after fission is less than the total mass before fission. So there is mass defect in nuclear reaction, and this mass defect is converted into nuclear energy. So similar to the previous question before. Okay, how nuclear energy is produced in this process. So write the energy transformation in nuclear reactors. So can you write the energy transformation in nuclear reactor? So how many types the energy has been converted until we get from nuclear to electrical energy? Okay, so first it begin with nuclear energy. Okay, nuclear energy produced inside the reactor from the nuclear fission of uranium. Second, it produced a lot of heat. The process produced a lot of heat. And this heat is used to generate the turbine. Okay, to generate the turbine. So when the turbine is rotating, so it involves kinetic energy. Okay, and kinetic energy finally convert to electrical energy. All right. Okay. So from nuclear energy, transform to heat energy, transform to kinetic energy, transform to electrical energy. All right. Okay. Next. Okay. One advantages of using nuclear energy, student. Okay, can you give one advantages of using nuclear energy instead of coal or hydro? What is one advantage of nuclear energy? So you can write more than one answer here. Okay. It is clean and no effect to the ecosystem and carbon footprint. Or you can say no air pollution or low operation and maintenance costs. Okay. Low operation and maintenance cost. And then B, again, the calculation. Find the mass defect, find energy release. So if you notice for this content standard 6.2, the question is just the same. Ask you to find the mass defect and ask you to find the energy release. That's all. Okay, that's all you need to calculate here in this part. So you are given this equation. Okay, so we understand this is nuclear fission. Okay, they give you the atomic mass unit for each element involved, and this is the conversion of 1 AMU to 1 to kilogram, and they give you the speed of light as well. So find the mass defect in kg. So you have to be very careful since you are playing with a lot of number there. Okay, so find the mass defect first. So this is the mass defect before reaction. This is the mass. This is the initial mass before reaction. This is the final mass after reaction. So by this, the mass defect is 0.19405 atomic mass unit. Okay, this is for neutron. This is for uranium. This is for cesium, rubidium, and 2 neutron there. Right? So it is just a plus and minus operation. Then energy release. So it must be convert into kg. So energy release E equal mc squared. So answer 2.8991 times 10 negative 11. Okay. So I think we have come to the final question here in this module, the long essay question involving nuclear power plant. Okay, this one. They give you a reactor, which is used to generate nuclear energy. So you are required to investigate the characteristic of the features. So they give you four choices there. Nuclear reactor P, Q, R, and S. First is the material for the moderator. Second, material for the control rod. Then material for the coolant and the thickness of concrete shear. So you can apply the tick to pick method. So you tick first. Which moderator is suitable, student? Graphite or iron? We use graphite or iron as the moderator, student. We use graphite or iron. If you follow the lesson, it must be graphite. Okay, so we take graphite. You take graphite. Okay. And what about the control rod? So control rod, either we use boron or cadmium. Two choices. So you see boron there. So we choose boron instead of krypton. Okay, then what about the material for coolant? Definitely we are using water and the thickness must be thick or thin. So the thickness must be thick. So can you see the best choices there? P, Q, R, and S. Can you see the four? Yeah, so we choose R as our best nuclear reactor. So then we write all the characteristic. Material for the moderator, graphite. Why use graphite? It is used to slow down the fast moving neutron. Or you can say graphite is not easily rust. Okay, that is additional answer. You can write for the reason. Okay, then material for the control rod, we choose boron. So what is the function of boron, student? To absorb excess neutrons or to control the rate of reaction. Okay, material for the coolant, so we choose water due to its high specific heat capacity, or you can say it absorb high heat, a lot of heat. Okay, and the thickness, thick. Why? To prevent leakage of radiation from the reactor core to the surrounding. So we choose R because it fulfill all the characteristic required for the nuclear energy to be run safely. Right? Okay. So choose R, it use graphite moderator, boron control rod, water as coolant, and thick concrete shield. Okay. So I guess that's all for today. We've learned about 6.2 nuclear energy together with all five learning standards. Okay, so I hope you're clear with the lesson. And if you have any further answer, as usual, you can stay here in this meet. If you have completely understood, so you can leave this meeting and continue with your Sunday activity. So thank you very much for your presence. Okay.